Okay, let's continue. My name is Fermín Galán. I'm in charge of the ContextBroker, which is the enabler within FIWARE which implements context management. And this presentation is about context management in FIWARE, and in particular how to use the ContextBroker to implement context management in your application. In fact, this is the first of a sequence of 2 talks. I mean, this is a first talk to date about the basic concepts in the context management API, and on Thursday, I think there is the second part, which is about advanced topics in the context management API. So this is my first presentation with an iPad, so please be indulgent if I do some mistake or something. Okay, I will skip the first part because I think that Juanjo has provided a very good introduction to context management in FIWARE from a high-level point of view, and which use cases and what are the reasons because you as developer will need to introduce context management in your application. So I will move directly to the low-level API, or in other words, the particular API that we have implemented in FIWARE to provide context management for your applications. Okay, basically the API implements 2 main functions. One of it is about context management itself. I mean, they are operations to manage entities and attributes, to create entities and attributes, read them, update them, and so on. And there is another part, but that part will not be described today because it's in some ways an advanced topic. It's about context management availability, in which case, instead of managing the context management piece itself, the entity attributes and its value, we are managing the source of that data. I mean, instead of storing, for example, temperature value is 13, we will store the entity or the actor, better speaking, the actor that has that information. In our terms, it is called a context provider. But as I told you, we will deal with that in another talks. Probably in the talk related with IoT, because it's very related with the Internet of Things layer in FIWARE. So we will focus today in context management. Okay, apart of that, regarding the nature of the API, I mean, which kind of API it is a REST-based API, as most one in FIWARE. In FIWARE, our common idiom is REST, so we try that all the APIs in all our components are based on REST. This is not true for all the cases, but I think that the most of them it is. And in particular, in the case of ContextBroker, the context management API is based on REST. And it's REST based on HTTP as transport layer, and we implement two renders. One of them is XML, and another one is JSON. We started at the beginning when we started developing the component with XML, but at the end, XML, I mean, JSON is usually preferred upon XML. So most of the developers prefer JSON, but it's important to know that we also have the other rendering if you need it. This presentation and in general this talk and the talk on Thursday will be based on JSON. I mean, you will not see any XML piece in this presentation, and I think that most of you will be using a JSON. Apart of that, it's important to remark the model in which the context management API is based. Is this model based on 2 basic concepts: entities and attributes. And entities are characterized, or I mean, the fields that define an entity are the entity ID and the entity type. Entity ID is an identification of the entity. For example, in the case of a car, could be the plate of the car. In the case of a user, could be the name of the user, and whatever other piece of information that univocally identifies that entity. And in addition, we also have the entity type. Entity type allows us to create categories of entities. For example, the entity type of the cars. So each member belonging to that type is in some way characterized as a car. So it allows to create categories of entities. And in addition, an entity can has a number of attributes. The number is not bound. I mean, you can use 1, 2, 3, or whatever number of attributes you need. And the attributes are defined by a name, which is the name of the attribute. For example, temperature, or position, or speed, or whatever will be the name. The type at the present moment is informative. It could be used in the same way you use types in programming languages, for example, to specify that the name is a string, or the temperature is a float, or whatever. But as I told, is mostly informative. I mean, ContextBroker is not doing right now any kind of enforcement of that type. And finally, the value. The value is the the value is redundant. The value of the attribute. For example, the value of the temperature could be 14, and the value of the speed could be 90 kilometers per hour, or whatever. It will depend, of course, the kind of the name of the attribute. And as you can see, this is a very simple model. I mean, it's very easy to use it, as you will see that in the next part of the presentation, in which I will start browsing the different operations you have. But before that, let me introduce the ContextBroker, which is the piece of software, the generic enabler in terms of FIWARE terms, that implements this API. It's a REST API, it's a REST server. In this sense, it's not very different from a traditional web server. It's a process running in a Linux machine, listening to a given port that by default is the 1026, but you can change it by configuration. So you can use, for example, 80 if you want to avoid firewalls or that kind of techniques. And in that port, the ContextBroker is listening and exposing the operation that compose the API. I have two kind of operation: the operation that are oriented to create context or update context, which are in the left part of the slide, and the actors to interact with ContextBroker in that way are called context producer, because they are the producer of context. And there is an operation, different variants called update, that can be used to create or update existing context elements, context pairs of entities and attributes. On the right part, we have the consumer. The consumer are the actors that will interact with ContextBroker to get that context information. So, and there are two kind of consuming context information. The basic kind is a synchronous way, a pull way in which the client performs a query operation and gets the result in the response. But there is also a way of getting the context using a push across of an asynchronous approach, in which the ContextBroker has different subscription programmed in it, and the ContextBroker send actively notification to the consumer that need to get that information. So instead of the consumer going again and again to get the context using query context in a synchronous way, the consumer can listen to ContextBroker, so ContextBroker will notify it's time, for example, a given attribute change. So we have these two ways of consuming context. A typical case of context producer could be a sensor. A sensor is the typical actor which creates context based on some measure of some physical magnitude, typically. And regarding context consumer, there is there is as many context consumer kinds of different application. Could be, for example, could be a system to draw a given attribute, for example, temperature in a chart in a web page, or could be a system that depending of the value of the temperature could raise alarms or whatever. It will depend entirely of your application. Finally, just to mention that ContextBroker persists the context. I mean, the ContextBroker has or interact with a database to store the context. So if you need to stop the service, the context is not slowed. When the ContextBroker starts again, it will read the context from the database. We are using MongoDB due to scalability reasons mainly. And another important thing to know is that this database is for storing the current context. I mean, the context broker is not for storing the temporal evolution of the different values of the attributes. To do that, we have other components within FIWARE. We can use, for example, Cosmos with data to that purpose. That will be explained next days. And there is a connector in ContextBroker that allows you to store the context evolution in that kind of persistent backends. But the bottom line of the important thing to remark is that ContextBroker is not for that purpose. ContextBroker is for storing the current situation, the current snapshot of the context of the system. Okay. Okay, so let's start describing the different operations exposed by ContextBroker. This is a very basic one, and in fact it's not related with context management, it's related with the health of the service. This is the typical operation you will do once you install a ContextBroker that you are going to start to use. This is the operation that you will do in order to check that everything is okay, in order to check that the ContextBroker is listening in a given port and is ready to process the actual operation. As you can see, the structure of the operation is a URL. Well, it's a HTTP verb. If you are familiar with REST, this will be very easy to get. We have a verb, which used to happen is the get verb, the verb to get information. We have a URL that is the host and the port in which the context broker is listening. And the URL is /version. /version is like, as I told before, like a ping to the process. It will report some information about the context broker itself at the version or the uptime or the particular the time in which it will compile. The bottom line is that you get that payload and you respond, the context broker is working okay, and it could do the actual context management operation. Which one? Which are the context operation, the context management operation? The ones that are described in the slide. As you can see, it's a very simple API. It only has 5 methods. In fact, 3 of them are closely related because they are related with, all of them are related with subscription. So at the end, it's like you have only 3 methods. So that means that the API is very simple. It's not an API with tens of methods. You only have to master 3 methods, and if you master them, you will learn how to use the component. Okay. And basically, there is a method for update, which is called update context, another for query, which is called query context, and there are 3 ones that are for creating subscription that are related with that function about notification to your context consumer. In fact, there is not all the API. I mean, this is the part of the API related with context management. The other part, which is related with context management availability, will be described as an advanced topic on Thursday. Okay. So, in order to illustrate how this API works, let's imagine a synthetic use case in which you have a context producer, which is a sensor installed in a car. So the car is driving by the city, and well, the sensor measures the speed that the car has. And in the other part, we have an application which is using that speed information to show it in the mobile phone. So we have a context producer and a context consumer. Okay. So the first thing that you do when you use ContextBroker, when you has just deployed a new ContextBroker with an empty database, is to create its own entities, the entities that your application needs. So in this case, we are going to create, or we are showing in this slide how to create the car one entity, the entity model in the car. Okay. So you have in the left part is this request. That request use the post method with a URL that in that case is localhost, but in a real case will be an IP or a DNS name or whatever. And you have the URL of the operation. This operation, the URL is /v1/update context, and this is the URL used to update context, to create new entities. And which entities, or what is the information about the entity to create, is in the payload. In the payload in the form of a JSON document. As I think you already know this is this kind of syntax with the brackets and key values is a JSON. And in that JSON, apart of some syntactic sugar, what we have, and it's remarked in red, is the information that makes that entity. We have an ID, which is car1, we have a type, which is car, and we have a vector or array of the different attributes. In a general case, we can add whichever number of attributes. In this case, we are adding just one, which is speed, and the initial value of speed is 98. And at the last line, you can see the update action line. This update action, which is set to append, means that we want to create a new entity, a new piece of context. There is another kind we will see next, which is update, which is for updating existing context. And so at the point, the client, the context producer, will send that operation to ContextBroker and will get a response. The response is the payload shown in the right part. That basically is like an echo of the request, and the important part is the OK that is highlighted in red in the last line. So, I mean, you can ignore the preamble, and if you read directly the status code and get 200 OK, that means that the operation got processed successfully. And what will happen in that case? Let me switch for a moment to a board that will represent the status of the ContextBroker along this presentation. So we can model this as a big database of context, which starts empty, and after that operation, what we have, if one entity, car1, with, speed set to 98. Okay, this is now the status we have in the ContextBroker. So I think, well, it's pretty simple. You are including in the request what you need to create that entity, the entity ID, type, and the attributes to initialize that entity. Okay. So imagine that the car, once the entity has been created, the car continues moving by the city, and of course the speed will change. So the new speed that the sensor is measuring is a new value, which is 110. So in that moment, the context producer installed in the car will send another operation to ContextBroker to update that information, to change the value of the attributes in the internal representation of the context that the ContextBroker stores. As you can see, the operation is pretty similar. I mean, we are using the same URL, v1/update context. The payload is basically the same. In this case, the vector of attributes will include only the attributes that are changing. In this case, the one is changing is the speed. And as a main difference is the last line. If you remember in the past slide, we will be using update context, but in this case we are using update. That means that we are changing the value of an existing piece of context. The response is very similar. You also can see the last line with the status code. And again, if the status code is OK, then your operation has been processed successfully. And upon that, what will change is that in the ContextBroker, the speed has changed for that speed of car 1 to 110. Okay. Okay, so that's all you need to know about updating and about creating and updating entities. This is the part, the role that the context producer will implement. But what about the consumer? What about the other part of the other side? The actor that needs to get that information to do something with it. The application running in the mobile phone. Okay, there is an operation for that. Is the query context operation, which URL is v1/query context. So the URL changes to means another thing. which is query, and the query that we are doing is described in the payload. So in that case, the case shown in the slide, we are querying for car number 1. We are querying, we specify the ID of the entity, the type of the entity, and when we send that query to the ContextBroker, we get that information in the response. In that case, in the request, the response is not just the status code. In the response, we get the information, and as you can see in the response, we are getting in that context response vector a piece of JSON that for the car number 1, and for the car number 1 we are getting an array of attributes in which we have the speed, and the speed with the value that we have just updated with 110. Okay, so this is current. The current status is 110, and that is the value that we get in the query context response. Okay, this operation is very flexible. There are different ways of querying. To illustrate that, let's progress and imagine that we the car again change the speed, and the speed has changed to 115. Whoa. Okay, we get an OK for that operation, and if I query again, what I get, this is the same query context, but if we given that we have changed the value to 115, what we get in the response is 115. So this is like a kind of cycle in which the producer will update the information, and the consumer will get always the most recent value. Okay. Okay, let's imagine another entity. Let's imagine that we create another entity of which ID is room 1. In this case, this is a novelty is that instead of having just one attribute, we have two ones. So we have this is specified as two different elements in the vector. So we have temperature and pressure. So we are creating note also the append in the last line. We are creating an entity called or identified by room number 1 with temperature 24 and pressure 7118. So that when this operation is processed at ContextBroker, what we get is another entity with temperature 24 and pressure 718, along with the other one. I mean, creating a new entity, of course, doesn't destroy the other entities you already have. So this shows another sample of update. In this case, we are changing the two attributes at the same time. So we're the temperature of the room is changing to 25, and the pressure to 720. So let's change this in the to represent that this has changed in the internal database. And if in this point we query for row number 2, we'll get the new value, the update value. Look at to this kind of query. In this case, different from the previous one that we use it for the car, in which we have all the attributes. We can filter the attributes we want. I mean, if we only are interested in temperature and not in the pressure, in the case of the room, I can add this the attributes vector at the end of the query to specify the list of attributes that I want to get. In this case, I want to get the temperature. So the response only, as you can see, only includes the temperature. The pressure is not included. In order to get the pressure, I have to do the query in that way, without specifying the attribute vector, or with the attribute with an empty list. In this case, different from the previous slide, you can see that I'm getting not only the temperature, but also the pressure. I'm getting the two attributes. This is very useful, this attribute vector, when I have an entity with a lot of attributes, think of 20 or 30 attributes, and I'm interested in only one of them or two of them. This is a convenient way of not getting a large response in which I only need to get only a few of attributes. Okay. Okay, let's imagine I create a new room number 2, with these values. Okay, so with, I think it was 33 and the other 72. Wow, no. Okay, so at this point I have two rooms, room number 1 and room number 2, with the same couple of attributes, temperature and pressure, with different values. And let's see how ContextBroker can be used to look for a set of entities, or more specifically to a pattern of entities. This is very similar to the previous one. I mean, we are using the same operation, query context, with the same structure in the JSON. But in this case, you can see that this pattern field that I haven't explained before. But if you have look at it, you have seen that it always got the value of false. If I use false, then the ID is interpreted literally. So the ID means the exact name of a given entity. But if I use isPattern set to true, what I mean in the ID is a regular expression. So in that case, and if you're familiar with regular expression, that syntax means whichever ID which starts with the 4 letters room followed by any character. This dot asterisk mean any character. So which entities match with this pattern? Well, we look to our database. This first one starts with room, and the other, and in this case the any character is 1, and in this case the any character is 2, but in both cases both entities match. Moreover, look that in the query we are using the attributes field, so we are specifying we only want the temperature. So in that case we are specifying that we want the temperature of both rooms. And as you can see in the right part, although it is a little bit small, the letter is a little bit small, but you can see there are two elements in the response, one for room number 1 and another one for room number 2, and each one has the temperature values in that message, and not the other, not the pressure. Okay, so this is we have seen the different ways of using query context. There is more stuff, for example, how to do queries in geographical areas, but although this is not covered today, but because it's an advanced topic. But the bottom line is that it's a very powerful operation that well, it can be used in a very flexible way. So to finalize with this overview of the different operation, let's describe a bit about this operation for subscribing and getting context in a asynchronous way. So in this case, this is based in the schema described in the slide. The idea is that I create a subscription in the ContextBroker. So I program in some sense the ContextBroker with a subscription, and in that subscription there is a triggering condition and an endpoint. So whenever that condition happens, ContextBroker will send a notification to a given endpoint. That endpoint has to be need to be a REST endpoint. I mean, your application has to have a server listening in that URL, so your application can receive the notifications. But apart of that, the ContextBroker will deal with sending that notification. Okay. So how it works? It works using the subscribe context operation. This is an operation that the subscriber sends to the ContextBroker. Again, it's follow the same pattern that the previous one. I mean the post bear with the URL, and in the URL we have b1/subscribe context. And regarding the payload, which includes the parameter of the subscription, you can see that the first part, the first fields, entities, and attributes are very similar to a query, because in fact a subscribe is like a query but doing in an asynchronous way. So you have a specification of the entity about you want to get the notification, the attributes, you want to filter by attributes. I mean, maybe you are not interested in all the attributes, and the rest of the payload includes the information that is specific of a subscription. We have a reference field. The reference is very important. It's the endpoint to which the notification will be sent. It's like the address to send the notification, and as you can see, it's an URL, and this is the URL that your receptor in your application will use to receive the message. We have adoration in the case you want to specify a subscription that ends after a given time. And you have the notify condition field. That is also very important because it's the field that explains under which condition the notification has to be sent. In particular, probably the most interesting type of condition is on change. That means that whenever the attribute value changes, the notification has to be sent. Which attribute is monitored for changes? The one that you specify in the const values. So in that case, the const values field specifies temperature. So basically, this subscription is meaning that whenever the temperature of room 1 changes, ContextBroker has to send in a notification that temperature. You can also see a last field called throttling. Throttling is used to specify like a wait time between notification. So if your receptor is not able to process notification at the same pace that they are being generating, for example, if they are 100 updates per second, and your application is able to process 100 notifications per second, you can specify some wait time, for example 1 second, and the ContextBroker will not send notification except if 1 second has passed before the last notification. So it's a way of controlling, of traffic control for your notification receptors. Okay, in the slide in the right part you can see the response to a subscribe context operation. It's not the information about room 1, it's just an ID that will allow you to manage the subscription. You have also methods to cancel the subscription, to update the subscription, but as you can see, the actual information about the entity is not there. Why it's not there? Because that information is supposed to be in the notification, not in the response to the subscribe context. So imagine that happened. I mean that in room 1 that current value of temperature is 25. The temperature gets down to 19. So that the ContextBroker will monitorize this attribute, and this is a case in which it has changed. So ContextBroker has to send a notification according to the subscription. And this message shown in the slide shows the structure of such notification. So ContextBroker will issue a post operation to the endpoint you specify in the reference. As you can see, this URL is the same that we have before. You can look to the slide, and that the reference is the same. It's a published URL in a given host and port. And in the payload, basically what we had, apart of the ID of the subscription, that is useful. You want to correlate notification with subscription. In the case that endpoint is for receiving notification of different subscription, this is a way in which you can identify which subscription produced that given notification. But apart of that, we have a context response vector. And in the vector is very similar to the one we have in a query context response. So, I mean, the codification is the same, the same encoding, and we have in that payload, in that message, we have the temperature. So the temperature has changed to 19, and we are receiving the 19 value in the given place within the JSON. Okay, we are more or less we are close to finish, but at this point maybe it's a good time to you have any question. I can ask them. Yes, there is a question over there. We have a mic that we can move, or okay, stand up and I will repeat your question for the streaming.
The first question is that let's say I have several providers, like several temperature sensors, and they're pushing information to the context broker. Each of them they have different internet connections, so some of them are faster than others, and they have different information. So do I have any way to give them different priorities to update information? Some of them are more important than others. Can I put some timestamp to say even this one has come later, it's actually older than the other one, or there's no way how that information gets updated, so not getting like false updates?
Well, in that case, you can model that information as part of the model of. Sorry. Yes, the question was about if we have different sensor and the sensor of different kind, and they are how to specify different priority for those sensor or different timestamps for the measure, and this kind of things. You can model that part of that information as part of your context. I mean, you can has an entity for each sensor, and apart from the actual measure of the sensor, for example, the actual temperature, you could include an attribute for the priority, another attribute for the timestamp, this kind of thing. You can model that as attributes, with a different concept that I haven't explained so far, because in some ways advanced, is the metadata. You can specify metadata linked to the different attributes. So you can specify that the metadata for that temperature, you have a metadata about the priority, another metadata about the timestamp, and this kind of things.
Well, let's say they are the same room, so they are updating the same value of the same. Sorry, let's say there are the three of them in the room. The three of them are updating the same entity with the same value, so it's temperature. And as far as I know, ContextBroker, I will query it to get me the temperature of this room. So which of those will I receive? Do I have a way? They get just smashed? The last one?
If the ContextBroker has some functionality in order, for example, to calculate calculate the average of the sensor, or the get the priority one of this kind of thing.
Which one would be the last one? It's first come, first smash the value, or?
ContextBroker hasn't that functionality. I mean, because the purpose of the ContextBroker is not doing that kind of aggregation, because that aggregation are very application specific. So your application may manage the priorities in some way, but other application may want to manage in another way. The same with average of this kind of thing. However, there is enablers within FIWARE that are intended to that purpose. There is one enabler called IoT Broker that is more or less this kind of functionality. I mean, you can has an array of a set of sensor measuring in the same, for example, in the same room, and this is a layer between your sensor and ContextBroker. So when you query ContextBroker for the sensor, this IoT broker is able to calculate the right question according to its internal programming. That's the idea. Okay, this is what you mentioned. This is your first question. You have another question? Another one? Okay. Is there any other question? Okay, first. It's for Juanjo. Yes. Okay.
Hi. You said there is intended to be more and more FIWARE providers, but I have an application which depends geographically. And because of regulatory rules, I cannot put it on another node. So I need a node in my area. How can I convince my technology provider to become a node? Is there a program for this?
Okay. Well, first of all, FIWARE is nothing that you take everything or nothing, right? It's actually your application may not require to bring all the FIWARE components, and it's something you will be able to set up on dedicated servers, your servers or the server of your let's say traditional technology or hosting provider. So it will depend very much on what is the kind of setting you are aiming at, that you really need for your application to run. Maybe there are some components of FIWARE that are enough, and then you can become your own FIWARE provider as such. So you may deploy the kind of the set of enablers and components that your application require, and then it's just open source you can use and deploy. There might be other cases where you need someone that actually becomes a FIWARE provider. For this, we are exploring several solutions right now. One of them is aiming at creating a sort of service which would allow you to automatically deploy a FIWARE instance in a set of dedicated servers you may have deployed on your premise or your favorite data center, right? And with some support to the deployment that is created through that service. So this is something that we expect to arrive to the market and be available during this year. So that would be another choice. But again, I want to insist, there is nothing that prevents you to pick up which components from FIWARE your application require, and then deploy them as you would deploy any other open source software, and do it wherever you want.
There was another question there, and
let me anyways, for the logistics, I think we have a coffee break waiting.
Yes.
So
it's waiting now.
so maybe a good solution would be that we stop here, have a coffee break. There might be some of the questions that might be
okay, but I think we can stop. But I think that after the questions.
Okay,
but
but some questions may also take place during the break. So let's just have 4 minutes for some questions. But
4 minutes for question. Maybe the two ones.
I mean, we have because they are waiting with all the logistics and the coffee and so on. So I suggest that we leave at quarter to 5, 3 minutes. So maybe take another question and the rest.
Okay.
Taken.
So
I proceed then?
Go ahead.
Okay. It's a question about the trap mode or the subscription mode of the ContextBroker. As we can see in the picture, it is supposed that every device, a small device, even a phone, should be able to connect to ContextBroker and make a subscription to being aware of changes. But most of the time these devices will be behind the firewall. So my question is, in this way of working, there should be a public IP or an accessible endpoint to make this device accessible, but sometimes it could not be possible. So is there any other way to make it, or should we make an in the middle machine for this, or perhaps is there a long life connection to solve this? I want to know if there is something you have think of.
currently the way of solving that issue is to have some kind of bridge in your backend in the backend of your application. I mean, you need to have a backend which listens to the context broker. You don't need a public API if you, for example, you can install in the same virtual machine in which context broker is. And those devices that need to get the notification and are not able to expose not only an API, but maybe, for example, in a mobile phone, it's don't used to make sense to expose an REST API in the mobile phone. But you can use then the mobile will connect to your backend using, for example, WebSocket or the kind of techniques. Currently, we are not providing that bridge. We know that it could be a very interesting piece because it's quite general purpose, so be useful for many applications. But currently, we are not providing that. I mean, your application has to implement it. It's in our roadmap to do that, but not yet. The last question, and with that question we will finish.
That's a short question. What is the protocol under publish-subscribe mechanism? Is it XMPP?
Is REST. NGSI.
Okay, but XMPP it's an extensible messaging and presence protocol. It's usually used in IoT to subscribe for information from sensors. So I was wondering if this is what is under this mechanism that you provide.
If you allow me to answer that question.
I mean in the backend, not when you want the information then you use REST, but under this mechanism on the server side, is it XMPP or something else?
I mean, again, as I explained in my opening speech, the notion of context that we are supporting is wider than what it comes from the Internet of Things and from sensors. Sensors are going to be part of the sources for context information, but it's not all. So the kind of protocols you are talking about are going to be supported because we are going to support connection to sensors, and one of the protocols to be supported is the one that you mentioned, as many others from
Thank
sensor.
you.
But it's going to be just a source, and then the whole idea is to allow that this information plus many other becomes available through a standard RESTful API that would be more convenient for the traditional web developer, and that is where NGSI comes. So I think we can stop now.
Yeah, we can stop. Let's go to the coffee break, and of course, if you can, I will be in the coffee break. So if you have more questions, you can approach to me, and I will.
We
try to
come
answer.
back here 5:15, I guess, no? Or what?
5:15 means half an hour of break.